All right, so example number 1 here, and let's get started. It says on most state highways, the fine for speeding depends on the speed of the car. In a certain state, the fine for driving 75 miles per hour is $25, and the fine for driving 85 miles per hour is $100. Assuming that this relationship is linear, write an equation for the fine as a function of the speed of the car. But first, they're kind of stepping you through what to do. They're telling you, these are the things that you should do. Even like this question here is what would be asked on the test, and they're having you go through the steps here.
Yeah.
Do that. So one of the ways to do this is to look at the units here and decide, does money cause the miles per hour, or does miles per hour cause the money? Like which leads to which?
The miles per hour leads to money.
That's right. So the input variable is the one on the left, and the output variable is the one on the right. Okay, so that's your answer. Miles per hour is the input, or the driving speed if you're trying to be more specific. And the output is the fine in dollars. Okay. Any questions on that before we move on to number 2 on the example?
No.
Okay. So it says, what 2 ordered pairs can be used to find the slope of the line? So that's why you got to define your input output, because you're looking for your MPH and your dollars as an ordered pair. And the thing is, what they'll do in this class, and it's college algebra or the one before college algebra?
It's college algebra.
College algebra. Okay. So on your test, they're going to switch these. They're going to flip the order here, or they're going to, they're going to be deceptive. Like they're not going to give it to you in the order that you want it to be in. So you got to say, okay, 70, 25. And then the other one is 85, 100. Right. So the next thing here is the slope. So what is the slope? Well, the slope is y2 minus y1 over x2 minus x1. 100 minus 25 over 85 minus 70. 75 over 15, and that becomes 5. Okay. Now the units of the slope, that comes from the units in the ordered pairs. It's the y units. Let me make that note here. It's the y units over the x units. So it's dollars per mile per hour. Or it could be written, actually in your test, it's written this way, dollars per mile per hour. So like one of the answer choices would be 5 on a multiple choice test with the units or the wrong units potentially. Okay.
Okay.
All right. What does the slope represent in this case? We still haven't sort of answered that. The slope represents the increase, because it's positive. That's why it's an increase. It's the increase in the fine for every mile per hour. So every time you go up another mile per hour, it's another $5. Another mile per hour, it's $5. Another mile per hour, it's $5.
Okay.
All right, now it asks for the x-intercept, which is strange. Typically, they ask for the y-intercept. So to do this, we need the equation. And the equation is, we can go y equals mx plus b. You already have the m value. The m value is 5. So to get the b value, you have to substitute an x and a y in. So you go back to one of your ordered pairs. We'll pick the first one here, 70, 25, and you put that in. So 25 equals 5 times 70 plus b. And then you just multiply this out. So it's 350, 25 plus b, subtract b equals minus 325. So that goes back in here. So your equation is y equals 5x minus 325. And so the x-intercept, now we can finally do the x-intercept. Like that's all kind of leads into the x-intercept. The x-intercept is when y equals 0. 0 equals 5x minus 325, and you solve for that. All right. So could you try doing that for us, please?
Yes. X equals 65.
X equals 65. Yeah. So now we got to give some like significance. I think this is probably the hardest part of like, well, what does that even mean? So what that means is the graph of this thing looks like this, where that's 65. So if you're not speeding, there is no fine. They don't give you money if you're not speeding. Okay, they like this is not valid. And that's the hardest part of this, is like the practical interpretation. Um, so you have to keep that in mind. Like you can't just say, well, it's good everywhere. It's that the function here, the equation is only good for when you break the speed limit. I mean, you're never pulled over for going too slow in most situations. That's a real rarity.
Mm-hmm.
Okay, so that's if you go back to the question, it says, what is the x-intercept and what is the practical significance at this point? That's probably the speed limit. That's probably the place where what the posted speed limit is.
Okay.
All right. So last one here. Sorry, just got to get back to wherever that was. There it is. All right. So what are the values, the independent variables for which the function is valid? Okay, so that's asking for the domain. So number 5 is really asking for the domain. Now we know that because it says independent variable. That's x. Domain is x. Okay. And we know that x is good from, well, whenever you break the speed limit. So it's not good for like 0. Like even though you could go back to this equation right here and put any number you want into it, practically you would only put in numbers there where you're breaking the speed limit. So the domain here is 65 to, as fast as you can drive, which I suppose is infinity. I mean, somewhat unreasonable, but that's kind of what they're looking for. The big thing is that you can't break the speed limit. Or, I mean, you can, but that's when the fine occurs.
Okay.
Okay. All right, so that's everything for example 1. Do you want us to go to example 2?
Yes, please.
Okay. Is the format of the class in person, online? What are you guys doing?
It's online. Like I go to one of the classrooms on campus, but the homework is all online.
Okay, but there's a physical, a human being teaching the class.
Yeah.
Okay, cool. All right. So example number 2, a business bought a machine for $25,000. After 4 years, the machine is valued at $10,000. Assume the value of the machine depreciates linearly. So that depreciates means that it goes down in price. It goes down in price, and it just depends on how much time. Okay, so the first question is the same as before. Is this a linear? Well, is this a linear function? It says that it's linear, so yes, it is.
Mhm.
What cues help you determine whether it's a linear function? Well, it says it. It says it's linear. I don't know. It's hard to be any clearer than that. Um, so I actually take that back. Two is the one that starts being the same. So you you got to decide like which causes which. Does and so you can write out both ways. Does time cause money, or does money cause time? And again, I'm just looking at the variables from the information that's given. What do you think?
Um, a time causes money. Um, so if it depreciates, I would say time causes money.
That's right. And I'm only writing them both just to show you there's only two options. If you already know it, you just write it down. But it's good to think of like what causes the other. So the input is time, how much time has passed, and the output is money, or the new value of it.
Yeah.
Okay. So then number three here is to write the ordered pairs. So let me gonna change my snipping thing here to freeform. That's what we want. Okay. So do you want to try to give me the two ordered pairs for this one?
Okay.
See what you come up with, or at least give me one.
Is one of them 4 and 10,000?
So the other one is something comma 25,000. And so when you start, when it's at the beginning, that's considered time zero.
Okay.
Okay, so now okay, so four is, we've kind of already addressed four because we've talked about the units, but we'll just keep going with it. It's hard to like talk about them like without really, you're talking about all of these things all at the same time. So it's like, what is the input variable measuring? Well, it's time in years is the input variable.
Mhm.
The output value variable is the value in dollars. What is the slope? All right, so I want you to use these two ordered pairs and come up with the slope. And you are allowed to use a calculator. I'm sure in the class
Mhm.
you generally have one at all times. So go ahead and calculate that for us, please.
Is it negative 15,000 over 4?
Yes.
Okay.
Did you come up with for that?
Um, is it 3,750 over 1? Or just
It is negative. So now your units come from, what are the Y units over the X units?
y is over the x? Is it money over time?
Per year, it's dollars per year. So you gotta be
Okay.
careful because time's not specific enough. It's dollars per year.
Okay.
All right, great. So that's really important because you're gonna be asked to either use that or find that. And then we can do the next part here, number 6, where we what are the intercepts and what do they represent? So the intercepts are, we've got X and Y intercepts. All right. And a graph of this thing, well, we need to first find the equation. I'm surprised they didn't say to get the equation. So it's Y equals minus 3,750 X plus B. And you have to use one of the points. Okay. Now you did get this point 0, 25,000.
Mm-hmm.
This is the B value. And the reason it's the B value is it's because at time 0, when X is 0, this goes away. So it's just that. Now, if you put that 0 in for X and 25,000 for Y, you still get B equals 25,000.
Okay.
Okay. But you want to be able to like shortcut that. So I guess let me just write it out in case you want to look at this later and you wonder why. So 25,000 equals B. And so you have Y equals minus 3,750X plus 25,000. Now, in your class, it's possible because they're talking about functions, function notation. It might be written this way: the function of T, where they put the B value first, 25,000 minus 3,750 B, like that.
Okay.
All right. So the graph of this look starts up here and comes down here. And so if you in 6, they're asking for the intercepts and what do they represent. And it's important to recognize that like you don't graph it to the left and you don't graph it to the right. The reason is, and we already know this is the dollars and this is the time. So you don't go into negative time over here and you don't go down into negative money, at least not in this problem. Okay, so they're looking for 2 things here. They're looking for the x-intercept and the y-intercept. Let's first talk about the y-intercept. The y-intercept is when t equals 0. When t equals 0, it's 25,000. And it maybe feels really repetitive, but 25,000 is the initial value. It's the initial value of the machine. And this is all case specific, but initial is truly initial. T equals 0 is initial.
Okay.
Now, the x-intercept, that's when you're coming down, 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 hitting right here.
Okay.
Okay. So what does that mean? Well, it's when the value is zero. So there's a time when the machine isn't worth anything. So the x-intercept is when you set f of t equal to zero. You're setting the whole thing equal to zero. 25,000 minus 3,750 t equal to zero. Okay, so I'd like you to try solving this for us, please.
Is it 6.66?
So we want to keep it as a fraction if we can, or yeah, take
Oh,
that back. That actually is okay. 6.6, probably 6.67 years. So the idea is that in 6.67 years, it's worth nothing. That's when it depreciates.
okay.
If you own a car and you own it long enough, it does eventually become worth nothing. So, okay, now an appropriate domain. That's part of, sorry for all the scrolling. That's part of this as well.
Mhm.
So the appropriate domain is well, value at 0 years to 6.67 years.
Okay.
So that is everything for example 2. There is an example 3, or we can go on to something else, which is, I mean, the other things I see here are some questions on finding the domain, extra practice, general form of a line, slope. Where should we go from here?
Um, could we uh move on, please?
To what? What do you want to go to next?
To let's see. Um, to like some of the questions about like functions.
Okay, is that so I'm looking at the first email you sent. Is that there? Like you just have to give me more help. Tell me where to go.
It should be in the first email, I believe, where it says like the grocery delivery app charge.
Okay, so I don't see it now. So the grocery delivery app charges, that's the one you want to look at.
Yeah.
Okay, let me see if I can find that. I do see kind of looks like you guys have like I don't know what they call it, grade scope.
Yeah.
Okay. Okay, so there it is. So the homework one, question 1, that's where you'd like to start here. Looking at.
Yes, please.
Okay, let me. I think I got it here. Okay, so if you don't know much about Gradescope, the way that it works is some of them are fill in the blank, and some of them you're uploading photos to.
Mhm.
So just keep that in mind. Maybe you already know that. It's kind of different in college, just the different way of doing things. All right. So a grocery delivery app charges a fee of $6.99 for a delivery order plus a service fee of 4.5% and of the cost of the groceries. Part A. So part A is the first one where you're actually submitting something. Suppose a customer orders $350 of groceries. What is the total fee that the app will add to the cost of the groceries? Include units in your answer. All right. Suppose that a customer orders $350 of groceries. Okay. So they charge, there's a fee plus 4.5% service fee. So it's like this is always there, the 6.99, and then the 4.5% changes based on how much in groceries that you order.
Mhm.
Okay. Any questions on that?
Um,
We're gonna do it. I just like, is that okay?
yeah, that makes sense.
Okay. So the fee is really the 6.99, and you can think of the fee as Y, but we're just gonna write it as fee plus 4.5%, 0.045 times the grocery cost.
Okay.
Okay. So in this problem, it says, what is the total fee that the app will add to the cost of groceries? So what I would do if I were answering this is I would write something like this, okay, like as
Okay.
my first line. And then the second line, I would write in like the fee equals 6.99 plus 0.045 times 350. And then I would write the fee equals and give that actual number here. Okay, so whenever you're ready, and you got to write this down stuff, you can even type it in while we're doing it. But go ahead and work this out and let me know what you come up with.
22.74.
And then the units are, well, it's money. You're being paid money. I don't know if you've looked into use those services before, but you're always paying. You're paying for those services. So of course the units are in money. And so like I would probably put the symbol beforehand like that. But that's what they're looking for in that box. That's how they're, when they grade it, they want to see your work. Make sure you hit save answer because it's easy to move on to something else. And yeah.
Yeah.
All right. So unfortunately, oh, there it is. There's like, where's part B? So they do this thing where they give you a bunch of parts, and then like for part B here, you have to actually submit a file. So you have to take a picture, upload it to your phone, or upload from your phone if you do it that way, or there's Cam Scanner, Genius Scanner, things like that. Okay, let me know when you're ready for us to move on to part B.
Okay.
All right, so for part B, it says create an equation to express the total fee that the app will add in terms of the cost of the groceries. So we actually already have that. That's this first line here. That's what I meant by sometimes you do stuff and you're doing it multiple parts here. But it says remember to define your variables and use proper notation. So that's where it's a little bit different. You have to define, well, what is X and what is Y? Okay, now X
Mhm.
is the input. What is the input in this case?
The
What is the input here?
the cost.
of the groceries. You gotta be more specific. So it's the cost of the groceries. Because the other cost is the fee, like the app fee.
Okay.
I don't even know if this is reasonable or not. It doesn't seem like enough for $350 for the groceries, but that's a side point, I guess. So why is the output? That's the fee. You have to be a little bit more specific. It's the total fee. Total fee in dollars. And I guess you could say the X is the cost of the groceries in dollars.
Okay.
So the equation here is y equals 6.99 plus 0.045x. So even though we used like words up above here for like fee and cost, you typically want to go back to x and y.
Okay.
So that takes care of that one. We can move on to part C here, which says, what is an appropriate domain? Justify your response. So the appropriate domain is, well, it's the X value. Okay, so the X is how much you're spending on groceries.
Hmm.
So like, what's the least you could spend on groceries,
Is
in
it
your
like
opinion?
the least amount you could, um, is it, is it 0?
It's zero, but I mean, you would never use the app and spend zero. So you would say does not include zero,
Okay.
right? Two, well, this is where I sort of have a problem because it's like, you don't spend infinite on groceries, but I guess you could, but I think
Hmm.
that's what they're looking for. Now it says to justify your response, which means that you probably want to, this is where I might ask the instructor. I might ask you say like, okay, my domain is 0 to infinity, but is that really the domain?
Okay.
Like, is it? I mean, that's where it's like, it's like the practical part of it. Like, even though you can spend infinite on groceries, I guess, I mean, I'm asking because I don't know. And I feel like that's like an important question to answer.
Yeah.
Right. And then let's see, is there a part D? I think there was, and I went by it. That was is this a function? Okay, sorry, I know I'm going slow. Maybe I'm going too slow here. I'm thinking back. I remember helping another student, maybe might have even been last summer on this class, and it was like, I remember all these same questions I had that never got answered. So is this a function? Yes, it's a function. Um, so yes, and then I guess You might want to go to your notes for this, but the general definition is that for every input, there is a unique output. That's kind of the standard definition, but you might want to check your notes and see if there's a more to it than that.
Okay.
Okay, question 2,
Okay.
I guess. It looks like that might be another email. You can I think you might also be able to next time download this as a file, like print to PDF. But
Okay.
I'm not sure. So let's take a look here. Question 2. Question 2 here. All right. So test market data shows that changing the price of a product changes the demand, the number of units that people are willing to purchase for a certain product. The test market data indicated the following. Do you know if you're going to into kind of the business program for?
Um, I'm not going into the business
Okay,
program.
so a lot of students do, and that's why they give you these kinds of questions, because there's this like premise that you're going to uh, go into that. And they
Okay.
give you these like demand supply questions. You'll see more of these in the course. So, all right. So does this table indicate the purchase price is a function of demand? So you're like what you're looking for, function of demand, that's the input. So you want to think of that as X, purchase price is Y. So what you're really looking for in functions are duplicates in X.
Okay.
And there are no duplicates. So this one is, and this is one of those again where I probably want to like ask my instructor, like, is it okay just to say yes, or do you need to give more like information?
I think the second part of part A is to explain why.
Was it? Oh, there it is. Okay. I'm not even, I'm look at the next question. Missed that altogether. All right. So it's the same thing. I mean, I hate copy and paste, but it's the same thing as this. For every input, there is a unique output. Like that is the justification, like every time for why something is a function.
Okay.
All right. So the next thing here, part. Wait, didn't we just answer that? No. Okay. Okay. Sorry. It's going the other way. Yeah. So the other thing that the class does is they like to switch the variables on you. And they're saying, if you go the other direction, is it still a function?
Mhm.
So they're saying now that assume that this is X and this is Y. Here's how we know that though. Does this indicate that demand is a function of price? When it says function of, that tells you the X variable. So price is now X, demand is now Y. Okay. So the answer is again, yes, because there's no duplicates. And why? And this is where like I'm worried that I'm giving you bad information because this is kind of the standard language. Like there's no duplicates. You don't have to worry about it. Do you know if you guys have talked about the vertical line test?
We have.
Okay. You might throw that in as well. In each of them, you could say passes vertical line test, but that is the same thing as this. And that's where I would, college is different than high school. Okay. And I'm not trying to like stand on a soapbox or anything, but
Mhm.
you have to get this information. Like you can't expect, um, you just can't expect uh, the um, them to like you don't get a second chance. Basically, you got to like go and find out this information ahead of time.
Yeah.
All right. Question 3. Flu patient. Does that sound right to you?
Yes.
Okay. I'll just ask because, well, I want to make sure we're doing the right thing. Yeah. Maybe this is in another email. I don't know if I've got all of this here. Oh, no, there it is. 3.1. There's part A. Sketch the graph of the function in an appropriate window. Label axes with variables and units. Label axes scales and label all important features such as intercepts, highest points, lowest points, etc. Okay, this is the function. Are you guys allowed to use Desmos?
Yeah, she said for homework we're allowed to, but not for like exams or anything.
Right. So okay, so you got to be careful with not like doing too much on Desmos, and then you get to the exam and you don't know how to do anything, right?
Yeah.
Because that would be a problem. I've seen that happen before. So um, we could do it on the calculator. I mean, it's very slow, but we can. That's not what I wanted. I wanted. Okay, there. I'm just framing this graph for you here to have something to look at here. All right, so if it were me, and this is not a complete, I'm going to make some adjustments here after I snip this in. But I would graph something like this. Okay. Now, a couple of things here that keep in mind. The domain, all right? Like flu patients prescribed, of course, antivirus, the milligrams of the drug in the bloodstream, P hours after the first dose is given. The domain is very important. It actually starts at 0. Okay. Like you need to exclude this.
Mhm.
Okay. And it does go on forever. So you want to make sure you indicate that it goes on forever. Like it starts, peaks, goes on forever. And this is true how medication works, by the way. You reach kind of a max, you drop off, and then if you get a new pill or something, it comes up again, and it eventually reaches some sort of steady state in there. But this is just showing you goes up, goes down, and there you have it. Now we do need to label this peak here. It is 6.25, comma 459.85. If you take calculus someday, you'll learn how to do that by hand. Um, And I would make a nice graph. Make sure you put the, put the kind of the major ones on here.
Okay.
These, and you got to label it. So this is time in days. Sorry, gotta go back and look. Now hours, time in hours. And then this is milligrams over here.
Okay.
So you got to make sure you label those as well. Now they might accept a screenshot. I don't know. It's because these are questions you find out, and what you don't want to do, like I keep referring to, you don't want to like wait till after you get your first grade back. You want to like ask these questions ahead of time so that if you need to make changes, you can.
Yeah.
And sometimes they're nice and they say, yeah, that's fine. Or sometimes just say to go to the syllabus, but
Yeah.
you got less margin for error in these college classes. So,
Yeah.
All right. Okay. So we can pick up on next parts here. Our next lesson will come from the graph. We're going to stop here.